Hello everyone. So we're going to have our first practice video about first order linear differential equation. So basically, we are going to find the general solution for the differential equations that are in first order and in linear form. So let's start by answering the first problem. 2x dy all over dx plus y is equal to 2. Now, how would we get the general solution for this differential equation? So, first and foremost, what I call this one, you need to have at least the idea on how would you solve it, which are the three steps in solving first order linear differential equation. Okay, so the first thing that you need to remember is you need to transform the given differential equation that are in first order and in linear form into its standard form, or SF in short. So what would be the standard form for the first order linear differential equation? The standard form for the first order linear differential equation is dy all over dx plus p of x times y, wait, hold on, plus p of x times y is equal to, wait, q of x. That's it. Okay? So this is the standard form for the first order linear differential equation. So what did you observe in this standard form? So first and foremost, there is no coefficient for dy all over dx except 1. Okay, so whether if it's a group of terms, constants, or function, there shall be no coefficient here except 1. Okay, next, for your p of x, they should be partnered with y. So obviously, when we say p of x, the independent variable itself is x. So that means we should have at most a term that has an independent variable of x. Okay, whether if it's a constant or basically a term that has x, okay. And the same thing here for q of x as well. So the explanation I had for p of x is the same explanation that implies or applies to the q of x. Okay, so after you transform into a standard form, now you're going to use this formula. U is equal to e raised to p of the integral of p of x. Okay? Because after you find your u, you're going to use this final formula, which is your u times y is equal to the integral of u times q of x. You're going to use this formula after you've transformed the given problem into standard form and you find your u. Okay? So that's it. Now let's apply it here. Okay? So let's erase everything here. So let's copy first the given. So we have 2x dy all over dx plus y, wait, there we go, plus y, nope, plus, no, wait, there you go, plus y is equal to 2. Okay, so there we go. Okay, now, is this in standard form? The answer is no, this is not in standard form. Okay, so by making it into standard form, we're going to simply divide both sides by 2x. Okay, so by dividing both sides by 2x, we will have dy all over dx plus y all over 2x is equal to 1 all over x. Okay, so is this already in standard form? The answer is yes, it is. Okay, So I can actually rewrite this one into dy all over dx plus 1 all over 2x times y is equal to 1 all over your x. Okay? So yeah, this is already in standard form. Okay? So in here, we can now locate your p of x and your q of x. Okay? So your p of x is this one. Okay? Which is 1 all over, wait, hold on. Let me fix that handwriting of mine. Your p of x is equal to 1 all over 2x. Okay? Then we have your q of x, which is this one. All right? So we will have 1 all over x. Okay. Now that we have your p of x and your q of x, now let's proceed to the second step. Okay, but before that, let's draw a border. Okay, what do you call this one? Let's draw a border here. Okay, so wait. So now that we are done with the first step, let's proceed to the second step. The second step here is you're going to use this formula. U is equal to e raised to the integral of p of x. Now, let's substitute 1 all over 2x as your p of x. Uh, p of x. So we will have e raised to the integral of 1 all over 2x. Okay. Now, what we're going to do is simply integrate. So the integral for 1 all over 2x is simple as, forgive me. The integral for 1 all over 2x is 1 half times ln of x. Okay. We can actually simplify this one. So by the definition of laws of logarithms, which to be specific, power rule, I can just simply bring back 1 half in here. So I will have u is equal to e raised to ln of x raised to 1 half. Okay? And by the definition of laws of logarithms, if we have e raised to ln of x raised to 1 half, therefore we will have x raised to 1 half, which is square root of x. So that is your u. Okay? So now that you have found your u, the next and the last step is to substitute it in this formula, which is u times y is equal to the integral times q of x. Hold on, wait. Okay. Now your u is basically square root of x times your y is equal to the integral of your u, which is once again is your square root of x times your q of x, which is your 1 all over x. Let me repeat that. 1 all over your x. Okay. Now, let's simplify. Okay. So this one on the left side, I'm just going to make it into like y times square root of x. Okay. Then on the right side, I can rewrite the square root of x as x raised to 1 half times for 1 all over x, we will have x raised to negative 1. Okay. So let's simplify this one further. So what should I write? So we will have y square root of x is equal to the integral of x 1 half times x raised to negative 1 will give you x raised to negative 1 half. Wait. This is actually small. Raised to negative 1 half. Okay. So now that we've already simplified everything, so we're going to integrate on the right side. So what is the integral of x raised to negative 1 half? So by getting the integral, you will have, let me copy the left side first. You will have x raised to negative 1 half plus 1 all over negative 1 half plus 1 plus c. Okay? So in here, we will have y times square root of x is equal to x raised to 1 half all over 1 half plus c. So here we will have y times square root of x colon is equal to 2x raised to 1 half. I plus c. Okay. So you can leave this as your final answer. Okay. But if you want to make it into what do you call this one? Into an equation that is y in terms of x, then there is no problem. Okay. But before that, what do you call this one? I can simply rewrite this as y square root of x is equal to 2 times square root of x plus c. Yeah. Okay, I forgot. Okay, that's it. And go. Okay, now, so you can leave this as your final answer, but just like what I mentioned earlier, if you want to make y in terms of x, there's no problem. So right, we have y square root of x is equal to 2 square root of x plus c. We can simply divide both sides by square root of x. Okay, which as a result, you will have y is equal to 2 plus c all over square root of x. Okay, wait, c all over square root of, wait, there you go, square root of x. That's it. Now, we can bring up the square root of x above, which would result to c raised, sorry, plus c times x raised to negative 1 half. So you can leave this as your final answer. So yeah, you can either uh, make this as your final answer, but if you want to make an equation y in terms of x, this would be your answer. Okay, so let's try another example. dy minus 4y is equal to x. So remember, the three rules here is first you have to make it into standard form, right? So do you think that in this equation, this is already your standard form? The answer is yes, it is already in standard form. Why? First and foremost, there is no what? There is no coefficient for dy all over dx. Second of all, we have your p of x as long as they're partnered with y. Okay? And of course, since it is p of x, make sure that the given inputs are at most has an x variable. Okay? And here, your x, this would be your q of x. Okay? So, that means this is already in standard form. Okay? So what we're going to do now is, what we're going to do now is to determine your p of x and your q of x. So what is your p of x? Your p of x is your negative 4. Okay. Then next, your q of x, it is your x itself. Okay. Now let's proceed to the second step, which is finding your u. Your u is basically e raised to the integral, wait, hold on. U is equal to e raised to the integral of your p of x. So what is your p of x? Okay, your p of x is basically negative 4. So we will have e raised to the integral of negative 4. So, what is the integral of negative 4? The integral of negative 4 is negative 4x. So, we will have e raised to negative 4x. Okay. So, we're done with finding your u, which is your second step. Now, we can now proceed to the last step. I'm going to draw a border here so that it would be much more convenient. Okay. Then, there we go. So, the last step is to use this formula. The formula is u times y is equal to the integral of your u times q of x. Wait. Hold on. Q of x. Wait. There you go. Okay. So let's substitute. Your u here is your e raised to negative 4x. Okay. Times y is equal to the integral of your u once again is e raised to negative 4x times your q of x, which is your x. Okay? So by simplifying the equation, we will have y times e raised to negative 4x is equal to, wait, hold on, is equal to the integral of x times e raised to negative 4x. Okay. Now that we've already simplified it, what we're going to do now is to, what do you call this one? What we're going to do is we're going to integrate this one. So how should we integrate this? Okay. We're going to apply integration by parts. Okay. But what we're going to use is the simplest method instead, which is your DI method. Okay. So this would be your letter D and we have your letter I. Okay. So D stands for differentiation and I stands for integration. Okay. And for the D, they have a columns for alternating signs. So we have positive, negative, positive, negative. Okay. So my D here will be my X. I'm going to use it to differentiate it. While for E, raised to negative 4x will be my I. So I'm going to use it to further integrate this one. So let's get first the derivative of x. What is the derivative of x? We will have 1, right? The next, let's go here. What is the integral of e raised to negative 4x? This is basically negative 1 all over 4 times e raised to negative 4x. Okay? Then next, okay, let's get the derivative for 1 here. What is the derivative of 1? 0. Okay? And let's get the integral for negative 1/4 e raised to negative 4x. We will have 1 all over 16 times e raised to negative 4x. So I'm going to stop at this row because as we differentiate the x, okay, we have 0 as a result, which is by one of the guidelines in using DI method, you're going to stop right here. Okay. Now, what we're going to do is we're going to multiply the x into this one and multiply negative 1 to this. Okay. So as a result, y is equal to y times yeah, correct. Y times e raised to negative 4x is equal to x times negative 1/4 e raised to negative 4x minus 1 times 1 all over 16 e raised to negative 4x plus c. So by simplifying them, we will have y times e raised to negative 4x. Oh, hold on. y, wait. Y times e raised to negative 4x, right, is equal to negative 1/4 x times e raised to negative 4x minus 1 all over 16 times e raised to negative 4x plus c. Okay. What I call this one, you can leave this as your final answer. Okay. You can leave this as your final answer. There is no problem with that. Okay. You can actually simplify this one. There is no problem. Okay. Because if you're going to simplify this one by factoring 1/4 and e raised to negative 4x, we will have e y times e raised to negative 4x is equal to negative 1/4 times e raised to negative 4x times 1dt x plus 1 all over 4. Okay? Plus c. Okay? You can leave this as your final answer as well. So, yeah, that's it. Or if you want to make your equation in terms of, if you want to make your equation, let me fix that. If you want to make your equation from like this one into y in terms of x, then there is no problem. So let me copy that again, the second answer. Y times e raised to negative 4x is equal to negative, wait, negative 1/4 x times e raised to negative 4x. So this would be x plus 1/4. All right, plus c. Okay. Let's divide both sides by e raised to negative 4x. So as a result, we will have y is equal to negative 1/4 times 1dt x plus 1/4 plus c all over, wait, plus c all over e raised to negative 4x. Okay, we can still simplify this one into y is equal to negative 1/4 times quantity x plus 1/4 plus c raised to plus c times e raised to 4x. Okay, so this is your final answer. If you want to make your equation y in terms of x. Okay, so that's it. All right, now let's proceed to the last one. Okay, so in the last problem, we have quantity x plus 1 times dy all over dx minus 2 is equal to 3. So is this in standard form? Obviously, the answer is no because we have a coefficient of x plus 1. So we're going to, we're going to uh, make this into a standard form. So let's copy the given first. So we have x plus 1 times dy all over dx minus 2y is equal to 3. Okay, so I'm going to divide both sides by x plus 1 to further cancel the coefficient for dy all over dx. Okay, so what I will have here is dy all over dx minus 2 all over x plus 1, hold on, all over x plus 1 times y is equal to 3 all over x plus 1. That's it. Okay. Now, this is already your standard form. Okay. So, Since this is your standard form, we can now label your p of x and q of x. So your p of x is equal to negative 2 all over x plus 1. Okay. And your q of x, what should I write here? And your q of x, this will be your 3 all over x plus 1. That's it. Okay. Now, what we're going to do now is to proceed to the second step. So I'm going to draw a border here. Okay, hold on. Okay. Now let's proceed. Let's find your u. Your u is, wait, your u is equal to e raised to the integral of p of x. Okay. So what is your p of x? Your p of x is negative 2 all over x plus 1. So we will have u is equal to e raised to the integral of, wait, the integral of, nope, again, the integral of negative 2 all over x plus 1. So what would be the integral of negative 2 all over x plus 1? So to make things short, the answer for that is e raised to negative 2 times ln of x plus 1. That's it. Okay. So how come did I get from in the integral of negative 2 all over x plus 1 into negative 2 times ln of x plus 1? Okay. So here we have negative 2 all over x plus 1. Okay. So here you're going to use u substitution. Let u be x plus 1. Okay. Then get the derivative of your u. You will have 1 times dx, which is, in other words, your dx. Okay? Then, find your dx. So, since du is equal to dx, therefore, your dx is equal to du. Okay? So, let's substitute. So, we have negative 2 all over, your u is x plus 1, so this is your u, times your dx, which is your du. Okay. Now, bring out negative 2, then get the integral of ln of u. So what is ln of u? Ln of, sorry, forgive me. So what is the integral of 1 all over u? So the integral of 1 all over u is just simply as ln of u. Okay? So, yeah, plus c. Therefore, okay, since your u is x plus 1, we will have negative 2 times ln of x plus 1. Okay? That's it. So that's how I got the answer here. Okay? So now that we've already found your u, now let's find the general solution, which is u times y is equal to the integral of your u times q of x. Wait. Q of, nope, there we go, times q of x. Okay, now let's substitute. Okay. Oh, wait. Before anything else, I actually forgot something. Wait. Wait, I forgot something. Hold on for a moment. Right, we have your u is equal to e raised to negative 2 ln of x plus 1, right? We can actually simplify this one. Okay. So by the power rule of logarithm, bring -2 here. Okay. So you will have u is equal to e raised to ln of, hold on, ln of x plus 1 squared. Okay. So wait, this is not a good handwriting. X plus 1, there you go, squared. Okay. So in here, since we have ln of x plus 1 squared, therefore we will have u is equal to x plus 1 squared. Okay? By the definition of laws of logarithm. Okay? So that's it. It's supposed to be -2, forgive me. It's supposed to be -2. Okay? So, wait, that's it. Ayan. There we go. So, we can now, request one, proceed to the last step. Okay, so this is u times y is equal to the integral of your u times q of x. Now let's substitute. Your u here is simply x plus 1 raised to -2 times y. Okay, which is equal to the integral of your u. Once again, it is x plus 1 raised to -2 times your q of x. Since your q of x is 3 all over x plus 1, therefore we will have 3 all over x plus 1. Okay, times dx. So let's simplify. So here we will have y times the what was 1 times quantity x plus 1 raised to -2 is equal to this one. I can actually combine this. I'll make this into a fraction. So this would be 1 all over x plus 1 squared times 3 all over x plus 1. Okay? Then, what I can do next is I'm going to multiply 1 over the square of x plus 1 and 3 all over x plus 1. So here we will have y times the quantity. What's this? Wait, my application is lagging. There we go. So y times quantity x plus 1 raised to -2 is equal to, here, if you're going to multiply these two fractions, we will have 3 all over quantity x plus 1 cube. Okay, that's it. So now that it is already simplified, we can now proceed to integrate this what was on this expression. Okay, so let's get the integral for this one. Okay, so we're going to use u substitution. Okay, so I will let u as x plus 1. Then let's get the derivative of your u. So I will have 1 dx. Or since it's 1 times dx, we can just simply rewrite this at your as your dx. So therefore, we have du is equal to dx. Okay. So let's now, what do you call this one? Substitute. Okay. So let's copy this one first. Okay. Y quantity x plus 1 raised to -2. Okay. Then here, this would be 3 all over u cube. Wait, all over u cube times your dx. Since your dx is equal to du, so we will have du. Okay, so let's simplify this one. Okay, but let me copy this one first. Okay, so here we will have the integral of, let's bring this u cube upward. So we will have 3u raised to negative 3. So let's now integrate this one. Okay, so by integrating 3u raised to negative 3, okay, we will have 3 times u raised to negative 3 plus 1 all over negative 3 plus 1. Hold on, wait. Plus 1 plus c. Okay, so here we will have the answer of y times quantity x plus 1 raised to negative 2 is equal to 3 times negative u raised to negative 2 all over 2 plus c. So this would result into y times quantity x plus 1 raised to negative 2 is equal to negative 3 halves. Okay, 3 halves u raised to negative 2 plus c. So this is your final answer. Wait, no, not yet. I forgot something. Do you know why? Remember that your u is your x plus 1. So therefore, okay, therefore, let's put it back again. So x plus 1, wait, there you go, x plus 1, oh my god, there you go, raised to negative 2 is equal to negative 3 halves times uh, x plus 1 raised to negative 2. There you go. Okay, so this could be your final answer. Okay, or you can actually simplify this one. All right, here, right, we have your this one. Okay, so if you want to make your equation in terms of y, in terms of x, meaning y in terms of x, then there's no problem. So let me rewrite the equation once again. So y times quantity x plus 1 raised to negative 2 is equal to negative 3 halves times x plus 1 raised to negative 2 plus c. Okay, we can actually divide both sides by x plus 1 raised to negative 2. Okay, x plus 1, hold on, there go, x plus 1 raised to negative 2. So we will have y is equal to negative 3 halves, wait, negative 3 halves plus c all over x plus 1 raised to negative 2. So in here we will have y is equal to negative 3 halves, wait, 3 halves plus c times quantity x plus 1 squared. That's it. See? So yeah, this is your final answer. If you want to make your equation in terms of if you want to make your equation y in terms of x. So yeah, that's it. That is actually your final answer. Okay, so I hope you have learned something from this practice video. Okay, so that's it.